Alright, we're in chapter 5, section 2, sinking funds. So in example 9, what we're going to do is we're going to compare amortizing or setting up a sinking fund. Okay, now I realize that I've been saying amortization wrong because it's not amortization, it's amortization like America. So I apologize for that. My husband corrected me and helped me get the pronunciation down. I had no idea I was saying it wrong. But now we're looking at, again, example 9. So a firm borrows $150,000 to be repaid in equal installments at the end of each year for 5 years. So we're doing 2 parts here, and then the first part has its own 2 parts. Okay, so first we're going to find the total cost under each condition. So the debt is amortized at 7%. So to find the total cost, the first thing we have to do is we have to find the payments. Okay, so we have to find our R. And again, this is annual, so that means every year. And then we're doing it for 5 years. So here are our little r, big R is the unknown, little r is 7%. Total annual cost, sorry, okay. So 7%, so 0.07, and that's annual. So that means I is going to be 0.07 over 1, or just 0.07. Up to you which one you want to use. Just again, use the one that makes most sense to you. And then here our n would just be 5, so we're doing 5 annual payments. So then we're going to, okay, and we know that it's going to be 1 year later because right here it told us the end of each year. So that's why we know we're not making a payment now. So then we're going to have 75,000. Our R is equal to that, and then this is amortization. So okay, so we're going to multiply by 0.07 over 1 times our loan amount, and then on the denominator we have 1 minus 1 plus 0.07 over 1 to the negative 5. So when we enter that in our calculator, we get 182,918 and 3 cents, because here again we have 0.0208, so we're going to round up, okay, to the next decimal. So then this right here would be our monthly payment if we were just going to take it as a regular loan like we would a home loan, but that's not what we're doing. So instead we're going to find the total annual cost. So here when we deal with the sinking fund, we have the interest and we have a regular sinking fund. So we're going to have to figure out our yearly interest. And then we're also going to have to figure out the sinking fund loan. So we also have to find R using this. Okay, so we have 2 things happening here. So our yearly interest is going to be 0.07 over 1, because that's once a year, times our loan. And I'm going to call that big I because it's an interest rate. So for that we're going to get 0.07 over 1 times 75,000. So we get 52,500. Okay, and then for our R, we're really just using the same timeline, but I'm going to make a fresh one because again we're trying to accumulate the principal. So because we're accumulating, we just want to make sure. And again, our first payment isn't till 1 year in, and n is still 5. But here our interest rate is 0.059 and it's still annual. So our I is going to be 0.059 over 1, which is going to be a little different than what we were doing up here. Okay, a little bit different. So this time what we're going to do is we're going to take this, and we're pretty much setting up a real similar equation. So we're going to do R equals 750,000 times 0.059 over 1 over 1 plus 0.059 over 1 to the 5 minus 1. So a little bit different, but very similar setup. So we get 133,313 and 22 cents, again rounding up that payment to the nearest penny, rounding up. Okay, again we rounded up the payment. So then here our total periodic payment is going to be these two together. And again, your book calls that TPP. If you see that in abbreviation, it's not abbreviated that way everywhere, it just depends on who you're talking to. So we get 185,813 and 22 cents, which is real close to what we were before, but it is higher, 3,000 per year higher. So not exactly going to be in your best interest. Okay, this would be your total periodic payment. Okay, so now part B. Part B. If setting up a sinking fund at 5.9% and interest paid at 7%, what rate would it be less expensive to amortize? So what we're trying to do here is we're going to take our regular payment. This is R, so we're going to set R equals to 185,813 and 22 cents. And then we're going to use this, but we're using our setup for a loan. So we're still considering this over here. And then 1 year in we make that payment, 2nd year in we make that same payment, and we're going to make it again over here at year 5. Okay, so we're still making 5, n equals 5, but here we're trying to figure out at what rate is it less expensive. So now we're trying to figure out what's our R. Remember, I here is going to be R over 1 or just R, so we don't have to worry about having a separate piece. But we're trying to figure out again which one would be cheaper, right? So this means that when you're looking at this later, it's like you're comparing two different payment plans, is really what we're doing. So we're going to take our 75,000, and that's equal to our 185,813.22 times 1 minus 1 plus R is the unknown, over R. So again, this isn't exactly easy to work with, so I'm going to make it 0 over here. Okay, and then we're gonna, this is the one where we make a table, we use that interpolation process. Okay, your book just says by good guessing, and it jumps straight to the answer, which isn't helpful if you haven't done this in a while. Okay, but this is not the first time we've done this. We covered it in chapter 1, we covered it again in chapter 3 and chapter 4, so we're coming back to this again. So that means it's one of those big ideas that you probably should know how to do. If you're concerned that it'll show up on a final, it will. And then I'm just going to use A as my R here. We'll set that up here in a minute. Just trying to get my equation in my calculator. Okay, so that's just what we did. And our current A is 0.007475. And we got something that's really big. Right, way too big. So we want to get a lot closer to 0. So let's try 5%. See how close that gets us. And then I'm just going to rerun that. So 0.05 would give us 54,474.01. So that's a lot closer. But we're still kind of further away than we want to be. So let's go up one more. 0.06, because this is much closer to 0 than that is. And run it again. So now we're even closer to 0. 32, whoops, I wrote that twice. 32,712.88. Okay, so let's do it again. .07. So now we're at 11,870.89 cents. So again, getting closer. Let's try 8%. And now we're negative. Okay, now we're negative. So that means our 0 is going to be somewhere between 7 and 8%. Okay, so let's try 0.075. Cut the difference. And we'll run it again. So we're at 1,778 and 90 cents. Okay, so now I want to look and I want to try to find that 0. This is still positive and my 8 was negative, so that means it's going to be between 7.5% and 8%. So let's say 0.076%, because this is already a lot closer, so it's going to be closer to 0.075, 0.076. Negative $213.94. So that's a lot closer than we were before. So, and we passed 0, so now that means we're somewhere between 0.075 and 0.076. So let's just go to one more decimal. Let's try 0.0755. Run it again. Now we get $781.43. So again, that's a lot closer. $781.43. Still a lot closer, but that means somewhere in between here we're going to be, and we're going to be closer to this. So let's try 0.0758 as our rate. And we get 183.95. So that's closer than that is. So let's try 0.0759, and then from there we'll just take whichever one is closest to 0. Running it again, negative $15.04. So we're going to take this one, because the 4 decimal places between this one, and this one, so those 3 that got real close, this one is the closest, and we're only going to go to 4 decimal places. Okay, so we're going to, that means R, write it over here, R is 0.0759. Now remember, whenever we write a rate as a final answer, we're going to do we're going to convert that to a decimal. So that means that our final answer would be 7.59%.